Hello viewers, in my screen you can see an innocent looking code that finds the user from database and update the user's balance. These are very simple lines of code, but this code can have a crucial issue. In this video, we will talk about that issue. At first, let's have a look what this code does. We have a table called users in our database, and in this users table we have a field called balance. So in that balance, let's say we have an initial value of 1000 for user 1 and 2000 for user 2. And here what we are doing is we are passing an ID in our URL, and then we are finding that user by the ID and decreasing the balance by 10 every time. So let's see if this code works as expected. So I will open my browser and paste this URL and hit enter, and let's go back to the database. So the balance is decreased by 10. If we visit this same URL twice again, then we will see that balance is decreased by 20. So this is pretty simple and it's working. But what can possibly go wrong? So let's think about it. In line number 14, what we are doing is we are finding the users, and then in that user we have the balance, right? Let's say we make two requests at the same time, and then both of these requests actually get this user find where the balance is 1000 for both of them. One request don't know that the other request is already updating the balance, so it will update the balance to 990, and then the another request will also update the balance from 1000 to -1, which is also 990. So even though we are making two requests that is supposed to decrease the balance by 20, but instead it is decreasing the balance by 10 only, which is for only one request. Well, if you are an optimistic person, you can think that this can happen very rarely. What if you are building an application that is visited by hundreds of users at the same time? And if you are not that optimistic, if we have a look at this code with a pessimistic view, for example, the pessimistic view is if something can go wrong, it will eventually go wrong. Instead of talking, let me show you what can possibly go wrong by simulating this case. So to simulate this case, what I will do is I will make a sleep statement here for 5 seconds, and I will make some space, and in the database I will make that value 1000 again, and in the browser I will open an incognito mode. So right now we have two browser open. One is normal mode and another one is incognito mode. So what I will do is I will copy this URL to here, and I will hit this URL in both of this window. So let me hit this URL here. It is taking time because we sleep for 5 seconds, and we hit this in incognito mode too. So after 5 seconds, if we go back to our database, if we reload the page, then you can see that it is decreasing by 10. So we don't want that, right? Because we made two requests, so we expected that it should decrease the value by 10 two times, which means 20. So we expect that the value should be 980, but it is 990, which is only one request. So in critical cases, if one user buy two items from your web application using his computer and his mobile at the same time, then in some cases he might end up charging only once, right? Why this is happening? Let me try to explain to you. So at first, request 1, find user, balance is 1000, and then it is sleeping for 5 seconds, right? Sleep 5 seconds, and then request 2. So in these 5 seconds, what request 2 is doing, it also doing the same thing. Find user where balance is 1000. So this is what's going wrong. So in request 1, it got the data from the database that the balance is 1000, and before updating in request 1, request 2 enter into the scene, and it is also saying that balance is 1000, and it also goes to sleep for 5 seconds. Then what happens is request 1 update balance 1000 minus 10 equal to 990, which is right. And then what request 2 does is request 2 update balance. So what is the balance in request 2? It is 1000, right? So it will say 1000 minus 10 equal to 990. So seeing this simulation, I think it is clear what can possibly go wrong. So now the question is what we want. So what we want is once request 1 find the user and get the balance. So before updating, no other request should get the user and balance, right? Which means something like this. So request 1 find the user, find the balance, get the balance and update the balance, and only then request 2 can get the balance, which should be 990, and then it will decrease by 10 from 990. Seeing this, you might think that what if we make this in a transaction? So let's try it out. Use ID, and then I will put these two query inside the transaction. So now I will make the balance to 1000 back again so that we can calculate easily. And then if I open the browser, request 1 made, request 2 made, it is taking time, executed. If I go to PHP and see the data, it is still 990, which is something we don't expect. Now we know that transaction doesn't help here, because transaction makes sure that if there are two queries that is modifying the database, if one query executed but another query failed, then transaction makes sure that the first query will be rolled back. But this is not the problem in our case. We don't want to roll back anything. What we want is we want to log the user. Let's say once one request log the user until that update is executed. So we want to log this user until the update is executed. Luckily, Laravel actually have the solution to this problem, and that is log for update. So once we find the user from the database, we log that user for update until this transaction is fully executed. As simple as that, and this is the solution to our problem. So if I make the database to 1000 again, saved, and then if I make two requests, request 1, request 2, taking time, and then if we go to our database, now you see the balance is decreased by 10 twice. So now it is not 990, it is 980, and this is exactly what we want. I believe now you know what can possibly go wrong with find and update and how we can solve that problem. My point is, even though Laravel have this function, you might not use it in your application because you might not think about this case. So in this sort of case, it is good to be pessimistic. That's it for today. See you in the next one. Happy coding.